Hi, I'm Torben Jansen from thoughtsonjava.org. Today I'm here to show you how to get started using Hibernate. It's probably the most popular JPA implementation and one of the most popular Java frameworks in general. Hibernate acts as an additional layer on top of JDBC and enables you to implement a database-independent persistence layer. It provides an object-relational mapping implementation that maps your database records to Java objects and generates the required SQL statements to replicate all operations to the database. But before we take a look at Hibernate's key concepts and APIs, please subscribe and hit the bell icon to get new videos every week. You can use Hibernate in different technology stacks, and each of them offers its own bootstrapping solution. In this video, I will use JPA's Bootstrapping API. It's easy to use and doesn't require any changes if you need to switch to a different JPA implementation. If you're using Spring Boot, or if you want to use Hibernate's proprietary Bootstrapping API, please take a look at the links in the video description. Before you can start using Hibernate, you need to add the Hibernate core jar to your project. I'm using Hibernate 5.4.1 in this video. After you've added the required dependencies, you need to tell Hibernate to which database you want to connect and which dialect it shall use. Dialects are an important feature in Hibernate. They enable you to implement a database-independent persistence layer by transparently adapting your mappings and queries. So make sure to always use the correct dialect for your database system and version. The easiest way to configure Hibernate is to add a persistence.xml file to the metainf directory. Here you can see an example configuration which tells Hibernate to connect to a PostgreSQL database on localhost. Let's take a closer look at the different configuration elements. I first define a persistence unit with the name myPersistence_unit. It defines a set of entities which represent the data contained in a data store and will be managed by an entity manager. The description element is optional. You can use it to provide additional information about the configured persistence unit. Then you need to define your managed persistence classes. These can be entities, embeddables, and mapped superclasses. You can reference these classes in different ways. In this example, I set the exclude unlisted classes to false. Hibernate will then scan all classes available in the current deployment unit to find entities, embeddables, and mapped superclasses. You can also use jar file elements to reference other jar files or class attributes to explicitly specify a set of managed persistence classes. The property element Hibernate.dialect specifies the database dialect which Hibernate shall use. In this case, I used the PostgreSQL 9.4 dialect to connect to a PostgreSQL database in version 9.4. The remaining 4 JavaX persistence JDBC properties specify the required information to connect to my local PostgreSQL database as the user Postgres. And that's all you need to do to configure Hibernate. You now know the basic set of configuration parameters to set up Hibernate and to connect to a database. Now it's time to take a look at JPA's Bootstrapping API and to instantiate your first entity manager. The entity manager is probably the most important interface in JPA. It allows you to persist and remove entities, to find existing entities by their primary key, and to create queries based on your entity mappings. Instantiating an entity manager is pretty simple. You just need to call the static method createEntityManagerFactory on the persistence class with the name of your persistence unit. That is the same name as you used in your persistence.xml configuration. In the next step, you can use the Entity Manager Factory to create an entity manager and use it to start a transaction. You don't need to start the transaction after you've created your entity manager. But please be aware that Hibernate will start and commit a transaction for each database operation if there's no active transaction. In most situations, it's better to start only one transaction. That reduces the load on the database and assures consistent reads for the duration of your transaction. After you've done that, you can use the Entity Manager to access your database by persisting, updating, or removing entities. You can also create database-independent queries based on your entity model. After you've performed all database operations, you need to commit or roll back your transaction and close the Entity Manager. You have now configured Hibernate and instantiated your entity manager. The only thing that's missing is a set of entities. An entity is a simple POJO with a set of attributes, a default constructor, and an entity annotation. By default, the entity gets mapped to a table with the same name, and each attribute gets mapped to a column of that table with the same name. At least one of the attributes has to map the primary key and be annotated with ID. Here you can see a book entity which Hibernate maps to the book table with the columns ID and title. Hibernate allows you to override the default mapping for the entity and all its attributes. You can annotate your entity class with a table annotation to define the database table and schema to which the entity gets mapped. And the column annotation enables you to customize the mapping of each attribute. For example, you can use the name attribute to define the name of its database column, exclude it from update statements by setting the updatable attribute to false, or reject null values with the nullable attribute. Most applications use a database sequence or an auto-incremented column to generate unique primary key values. If you define it in your entity mapping, Hibernate automatically handles the required steps. I explained the different options in great detail in how to generate primary keys with JPA and Hibernate. So I keep this description short. You just need to annotate the primary key attribute with generated value and specify which generation strategy Hibernate shall use. In this example, I use Hibernate's default sequence to generate a primary key value. Most attributes don't require any additional mapping information because Hibernate gets all information from the specific class. But if you're using enumerations or Java util date or calendar, you might want to customize the standard mapping. Let's start with enumerations. Hibernate supports two options to map an enumeration to a database column. You can either use its string representation or its ordinal value. Hibernate uses the ordinal value by default. It's an integer which represents the position of a specific value within the entity definition. If you prefer the string representation, you can annotate the attribute with enumerated and set the enum type to string. I explain this mapping in more details in one of my Hibernate tips. You can find a link to it in the video description. Okay, let's take a look at the mapping of Java util date and calendar classes. One of the disadvantages of these classes is that they always model a date with time information. But that's quite often not what you want to persist in your database. In a lot of cases, you just want to store a date without any time or a time without a date. The classes of the date and time API fix this issue. JPA and Hibernate support them as basic types. If you have the choice, you should use this new API. It provides a lot of benefits, and the easier attribute mapping is just one of them. If you need to use the old date or calendar class, you can customize the mapping with a temporal annotation. It enables you to map the attribute to a Java SQL date, time, or timestamp. In addition to the basic attributes, Hibernate also allows you to model the associations between your database tables as entity attributes. That makes them extremely easy to navigate in your business logic, and you can even use them in your JPQL queries. JPA and Hibernate support the same associations as you use in your entity relationship model. You can map an uni and bidirectional one-to-one, one-to-many, many-to-one, and many-to-many association. Explaining the different mappings would take way too long for this video, but I did that in great details in my ultimate guide to association mappings with JPA and Hibernate. And if you're already familiar with the basic association mappings, you should take a look at the links to some advanced posts and videos about best practices and common pitfalls. You can find the links in the video description. Inheritance is another advanced feature which you might not want to use if you implement your first application with Hibernate. It's one of the key concepts in Java, so it's no surprise that a lot of developers use it in their domain model. Unfortunately, relational databases don't support this concept. But JPA and Hibernate provide different mapping strategies that allow you to map your inheritance hierarchy to one or more database tables. You can read more about the different strategies with their advantages and disadvantages in my complete guide to inheritance strategies with JPA and Hibernate. You can find a link to it in the video description. After you've defined your entity mappings, you can use them to create, update, or remove a database record by persisting, updating, or removing an entity. The Entity Manager provides an easy-to-use API for it that doesn't require you to write any SQL statements. You can persist a new entity to a new database record by instantiating an entity object and calling the persist method on the Entity Manager. If you run this code and activate the logging of SQL statements, you can see that Hibernate generated and executed an SQL insert statement. Updating an existing entity is even more comfortable. You just need to get an entity from the database and change any of its attributes. The find method of the Entity Manager gets the entity with the given primary key from the database. I explain it in more details in a few seconds. For now, let's talk about the update. Before you execute the next query or when you commit the transaction, Hibernate will perform a dirty check on all managed entities to identify any changes. It then generates and executes the required SQL update statements. And you can remove an entity by calling the remove method on the Entity Manager. Hibernate will then generate and execute the required SQL statement to remove the entity. JPA and Hibernate provide multiple options to get an entity from the database. You can use the Entity Manager to get an entity by its primary key, or you can define complex queries based on your entity model, or you can execute a native SQL query. Let's start with the Entity Manager. If you just need to get an entity by its primary key, you can use the find method of your Entity Manager. As you can see, you just need to provide the class of your entity and its primary key. Hibernate then uses the mapping information of the entity to generate an SQL select statement. It selects all mapped attributes of the record with the given primary key from the table mapped by the entity. You most often need to select multiple records, or you want to filter them by attributes that are not part of the primary key. You can do that with a JPQL query, like the one that you can see here. JPQL is a query language similar to, but not as powerful as SQL. It enables you to define queries based on your entity model instead of the underlying database tables. You can learn more about it in my ultimate guide to JPQL queries with JPA and Hibernate. If your query is too complex for JPQL, or if you need to use any database-specific features, you can use a native SQL query. It allows you to execute plain SQL statements within the context of your current transaction and persistence context. You can see an example of such a query here, and I explain it in great details in how to call native SQL queries with JPA. As always, you can find links to all the articles and videos that I mentioned in this video in the video description. Hibernate provides an easy-to-use and powerful option to persist data in a relational database. It acts as a layer on top of JDBC and maps your database records to Java objects called entities. You can use these entities to read, persist, update, and remove database records. Based on the operations you perform on the Entity Manager and your entities, Hibernate generates and executes the required SQL statement. Okay, that's it for today. If you want to learn more about Hibernate, you should join the free Thoughts on Java library. It gives you free access to a lot of member-only content like a cheat sheet for this video and an ebook about using native queries with JPA and Hibernate. I'll add the link to it to the video description below. And if you liked today's video, please give it a thumbs up and subscribe below. Bye!